A pleasant day, everyone. Today, we will be discussing the three subatomic particles of an atom, which is the protons, neutrons, and electrons. This is the most essential learning competency for this lesson. Determine the number of protons, neutrons, and electrons in a particular atom. And these will be our learning objectives for this topic. A. Locate the atomic number in a periodic table. B. Determine the number of neutrons from the mass number. C. Identify the number of protons, neutrons, and electrons in a particular atom. From the previous lesson, you have learned that an atom is a building block of all matter, comprised of three subatomic particles known as protons, neutrons, and electrons. They have their respective charges, mass, and location. Please look at the table below to help you recall these subatomic particles. Upon learning this essential information, I know you want to know more and further explore atom. Have you ever wondered how many numbers of protons, neutrons, and electrons in an element? Yes, you heard it right. Element is made up of atom. I think you have an idea where you can find the elements. Where? Yes, it is in the periodic table of elements. All of its information is in the periodic table. It is needed to determine the number of subatomic particles in an atom. Take a look at this example. Most of the periodic table uses this format, where you can find the atomic number, element symbol, element name, and atomic weight. What is atomic number and mass number? Atomic number is equal to the number of protons in the nucleus. It is unique for each atom of an element. Its shorthand symbol is letter Z. Mass number is the sum of the number of protons and neutrons of an atom. Its shorthand symbol is letter A. Take a look on the illustration below. This is the symbol representation of mass number and atomic number. We will be using this one during our discussion. Now, how can we determine number of neutrons from mass number? Atomic number and mass number can be easily found in our periodic table of elements. So don't forget to secure one. Take your time to explore and get familiar with those elements. In determining the number of neutrons, you just simply get the difference between the mass number and the atomic number. So number of neutrons is equal to the mass number minus atomic number. Here are the simple steps in determining the number of neutrons. Step 1. Find the element in the periodic table and get the mass number and atomic number. Step 2. Plug in the values in the symbol representation. Step 3. Operate by subtracting the atomic number from mass number using the formula. Let's try. Let's answer this example. Identify the number of neutrons of a chlorine atom. Step 1. Find chlorine in your periodic table and get its mass number and atomic number. Atomic number is equal to 17. Mass number is 35.45, or round off to 35. Always remember to round off the mass number. Step 2. Plug in the values in the symbol representation. So we have here the mass number, atomic number, and the element symbol. Step 3. Operate by subtracting the values using the formula. Number of neutrons is equal to mass number minus atomic number. Therefore, 35 minus 17 is equal to 18. Number of neutrons of fluorine is equal to 18. To determine the number of the remaining subatomic particles, rules must be followed to identify the number of protons, neutrons, and electrons. Rule number 1. The number of protons is equal to its atomic number. Rule number 2. In a neutral atom, meaning no charge, the number of electrons is equal to the number of protons. Rule number 3. The mass number is equal to the sum of the number of protons and neutrons. Rule number 4. The number of neutrons is equal to the difference of mass number and the atomic number. Example. We will first use the steps in determining the number of neutrons. Find the number of protons, neutrons, and electrons of aluminum. So our given atomic number 13, mass number 26.982 is rounded off to 27. Plug in the values in the symbol representation, wherein 27 for mass number, 13 for atomic number. Rule number 1. Number of protons is equal to the atomic number. So the number of protons is equal to 13 since the atomic number of aluminum is 13. Rule number 2. In neutral atom, no charge, the number of electrons is equal to the number of protons. Our number of protons is 13. Therefore, number of electrons is also 13. Rule number 4. The number of neutrons is equal to the difference of mass number and atomic number. Number of neutrons is equal to mass number minus the atomic number. Number of neutrons is equal to 27 minus 13. Our mass number for aluminum is 27 and our atomic number is 13. 27 minus 13, that is equal to 14. Therefore, number of neutrons is equal to 14. Therefore, aluminum has 13 protons, 14 neutrons, and 13 electrons. Now, can you try this at home? Find the number of protons, neutrons, and electrons of a silicon atom. Your timer starts Now, let's check your answers. Protons 14, neutron 14, electrons 14. Good job, everyone! I hope you got the correct answer. To learn more about the number of protons, neutrons, and electrons, you can check out this link. You can explore more by adding protons, neutrons, and electrons. Enjoy! Remember this. In determining the number of neutrons in an atom, get the difference between the mass number and the atomic number. In determining the number of protons, electrons, and neutrons, the following rules must be followed. The number of protons is equal to its atomic number. In a neutral atom, the number of electrons is equal to the number of protons. The mass number is equal to the number of protons and neutrons. The number of neutrons is equal to the difference of mass number and the atomic number. Let's practice more. For your assignment, find the number of protons, neutrons, and electrons of this element. After watching this video, don't forget to answer your science module, quarter 3, module 6, the number of protons, neutrons, and electrons. Hope you enjoy our lesson for today, and thanks for watching.